Welcome back to Nebula Flames. I hope you all are doing good, and in this video we will be talking about one of the most crucial part of our astronomical gear setup, and we will understand the basics and what are the types of this part. This will help us understand that while making purchase which one to go for and which one will give us the best output according to our requirements. So without any further ado, let's begin. When it comes to astronomy in the whole world, most of us, those who are like new or somehow they got to know about astronomy and got very curious and they want to pursue or at least explore the astronomy. They want to see the moon closer or the Saturn rings, how they look, or how the clouds of Jupiter looks like. But in all of these scenarios, we mostly think about one mostly used equipment, that is telescope, if I'm not wrong. And when it comes to telescope, most of us get that one image in our mind, that is of the OTA. OTA is nothing but optical tube assembly, and optical tube assembly is nothing but the tube that contains the optical parts and that helps us magnify that particular selected area that we point at, and we can see that area closer to our eyes and we can observe the details of that area more closer. So this OTA is not enough, if you all know, because we need some kind of tool to attach it so that we can peacefully observe or capture the images of beautiful astronomical objects. If we talk about those remaining parts apart from the OTA, that is, first is the tripod itself. If I show you the tripod, like the basic one, like just consider this is the tripod. If you can see, then it contains 3 legs, okay, and these 3 legs is connected with the upper head, which connects further with another part, and that another part connects with the OTA. So here the main logic about the tripod is, the stronger the tripod, the heavier payload capacity it can handle. That's the basic understanding of a tripod. But there is another technical part that sometimes we avoid, that is, the stronger, the heavier the legs of tripod is, the more stable it gets. And those who all do astronomy, or you can say astrophotography, the serious one like deep space, they all know very well that how important it is to have a stable tripod and avoid shakes that actually destroys the data that we capture. So we understood what is a tripod, and now the important part, or you can say the neck of the whole setup, that lets us point the telescope at any part of the sky and enjoy the object. So that one part is mount. Yes, that mount is really important for the whole astronomical setup, and depending on which type of mount you are going to choose, that will decide that what kind of pursuing you are going to do in the field of astronomy. Mainly there are 2 types of mounts, and one of them is Alt-Azimuth. If I tell you briefly, it is known as altitude azimuth, and the second one is EQ mount. EQ mount stands for equatorial mount, and this equatorial mount is really good for long exposures and deep sky astrophotography. But we will first understand about altitude azimuth. I will call it shortly Alt-Azimuth, okay? So when it comes to Alt-Azimuth, it has only 2 axes that it can move on, that is altitude and azimuth. So that's why it is known as Alt-Azimuth, and the telescope is limited in that kind of setup. It has its downsides and positive sides as well. But first of all, we will discuss how it works. So to explain Alt-Azimuth mount, I will use this. If you can see this properly, I will explain you what is an azimuth is first. When it comes to azimuth, the axis of azimuth moves like this. This is the first axis, you can say, the azimuth, okay? like this. Now we understood what is azimuth, but there is another axis called alt, you can say altitude. In altitude it moves like this, wait, yeah, like this. Okay, so these are the two axes only it can move, and there is a really big downside of this setup, that is field rotation. When it comes to field rotation, it really destroys the amount of that data we capture. Even though if we set up a go-to you can say system on the Alt-Azimuth mount, it is going to for sure destroy the data a little bit because of the field rotation. No matter how much you try, it's gonna have that field rotation in longer exposures. This is the very big downside of it, but there are positive sides as well. In positive sides, it is very simple to use. You just set it up and point it anywhere and enjoy the view. It is really good for, you can say, the direct observation from your eyes, from your vision, but not really good for astrophotography, especially in deep space or deep sky like galaxies and nebulas, because you need to take longer exposures. But yes, there is planetary photography that you can do it, because in planetary photography the field rotation can be avoided because you don't capture for longer exposures, you just capture some seconds of frames really fast. Okay, because of this the Alt-Azimuth is really limited because of this kind of facts. So because of all these points, the Alt-Azimuth mount is really down for your long exposure. I hope you understand it. The field rotation is the key point that is actually making it go down when it comes to Alt-Azimuth mount. So we have understood how Alt-Azimuth mount works. The Alt and Azimuth axis is also used in our EQ setup as well, but it is in a little bit different way. I will explain you how it works. So with this, let's move to our second type of category, that is EQ mount, or you can say equatorial mount. When it comes to EQ mount, or you can say the equatorial mount, it is consists of the Alt-Azimuth mounts, both of the axes, as well as another two axes that is actually used to track the sidereal movement of the sky. So first is azimuth, and the second is altitude, that we have already understood how that axis moves, and the another is right ascension, and the last one is declination. So to show you how the movement of this axis are, for your better understanding, I will use my equatorial mount that I use for my astrophotography. So let's get the mount here. So we have our equatorial mount set up over here, and here you can see that it is just the mount. I have removed the counterweights from here so that I can easily explain you the working mechanism of this mount. This is an EQ mount or equatorial mount, and this is EQ3, means equatorial version number 3. This is known as German equatorial mount. Here you can even read, it is written here. If I can, I will attach the image here for your reference. So let's start. How many axes are there? I will show you. 1, 2, 3, and this is 4. There are 4 axes, and Alt-Azimuth axes are already here. This one is azimuth axis. Let me make it loose so that I can show you. It moves like this. This is an azimuth axis, okay, and this one is mostly used for polar alignment in equatorial mount. If you guys want a dedicated video on how to do perfect or nearby perfect polar alignment, because if you have a setup like this is actually too much wobbly, and this setup itself is not so perfect. It has a lot of negative sides when it comes to a serious astrophotographer. So If you want a serious dedicated video related to polar alignment, comment down. I will make it for you guys. Okay, so we understood that it has azimuth and altitude axis. Altitude axis of course moves like this. See, here I have locked this axis because there is particular altitude level that I need to maintain for polar alignment according to my location. This is according to my location. Okay, now we are clear with this and this. This is azimuth and this is altitude. Sorry, not this, but this is altitude because it is moving at this axis. See, like this. Okay, and this one is azimuth. This is only used for polar alignment. Once you do polar alignment, you don't need to touch this axis at all. These two axes are gonna be locked. If you have perfect polar alignment, do not touch this axis at all. But when you do tracking or pointing to any object, these two axes, that is right ascension and declination, these two axes are most of the time used for pointing to any object or tracking with sidereal rate for longer exposure. Now let me show you first the right ascension. Let me make it loose. These are the clutch, or you can say lock, for locking the axis so that it can be moved by the motor or any system you attach to it. So here we are moving right now right ascension axis. Okay, when we are doing tracking of our sidereal rate, when we do tracking on sidereal rate of our celestial objects, at that time we need this axis 99% of the time. If you have polar alignment perfect, then you only need this axis 100% of the time. This moves according to the sidereal rate slowly, like this, and it moves with the object in the sky that you are pointing on. And we use this axis movement for long exposures or tracking or the movement of any celestial object like moon or any planet or sun or any object in the whole space. We are done with RA, or you can say right ascension axis. The another axis, that is declination, or in short it is known as deck axis. I will unlock deck axis as well. We have to lock this so that when we are doing capturing, it will not move automatically because of weight or any kind of movement like blowing of air and all. So we will move the deck axis, and this is how the deck axis moves. I hope you are able to understand. This is deck axis movement. Here we have only deck axis movement, and this one that I show you, this is right ascension, and the whole setup rotates on azimuth like this. I have made it tight, I think. Azimuth like this. This is azimuth, and this one is altitude. I will repeat. Only azimuth and altitude axes are used for polar alignment. When you are done with polar alignment, lock this axis the best possible. Do not let it move. Lock your tripod, or if you can mark somewhere so that you can do your day-to-day polar alignment very easily. When you do the polar alignment, you don't need to touch this at all. Only this RA and deck axis are going to be used in your entire astrophotography, you can say, session of your whole night. So there is nothing else to explain when it comes to the equatorial mount. And lastly, here is the place where the telescope sits. Okay, like this here, and it moves with this, or this, and here we put counterweight. I'm explaining you all this because it is related to equatorial mount, so that you can understand what is an equatorial mount. So the most important part, that is the field rotation. The field rotation is the major problem when it comes to only Alt-Azimuth mount, but this one solves it very easily. And how it does is, this array that you know, that we just now understood, this array, that is right ascension axis, is actually aligned with the center part of the earth, means the center rotating part of the earth. How to say, like center of the earth, right? We are actually targeting or pointing this right ascension, the center point of this right ascension, to the north pole, or you can say the center of the north pole, exactly on the polar star. But let me tell you one interesting fact, that polar star is not exactly in the center. Yes, it is not in the center, but actually there is no star that is really bright in the center. That's why we have to consider the closest possible bright star, that the one that we today know as Polaris. So we try to point this on the Polaris, and if we try to do more accurate polar alignment, then to the center of the North Pole. And this is all the basic part of it, very basic, that we have understood that how equatorial mount works. So I will put this on the side. So I think I have made a very easy understanding of the difference between two types of mount, that is Alt-Azimuth mount and an equatorial mount. So I will tell you a little bit more about these mounts. When it comes to the different types of mount in both of the category, there are, you can say, no limits, but I will make it more easier for you to understand that you can see this as in two different kinds. That is, one is go-to, or you can say computerized automatic mount, and the second one that you already know, that is manual without computerized. The one that you saw right now, it is non-computerized. I have attached a motor to it, but if you buy it, you will get it without any computerized system. So when it comes to the EQ3 that you already heard in some seconds ago or some minutes ago, what is an EQ3? It is a version. There are EQ4, EQ5, EQ6. Each and every version increment adds more and more feature to that mount. So for example, in this EQ mount, you saw that there were no space or no design for, you can say, the polar scope. And if you move to EQ4 or EQ5, you will see that there is space for polar scope. But let's say if EQ4 doesn't have space for attaching a go-to system, then the EQ5 must be having space for attaching go-to system. Let's say there is EQ6, there must be an advanced version of the go-to system. So it depends on the version, that what kind of features is being added to it. There is not a big rocket science in that. That's how we understand the different version of equatorial mount. So now let me make you more easier for you to decide. Those who really serious about doing astrophotography, like deep space or deep sky, in which the nebulas, very faint nebulas as well, very faint galaxies as well, it really needs a long exposure. This long exposure helps you get that hidden data, the hidden portions of the object. Either it is a dust cloud of any nebula or some clouds of the galaxies. But if you are not really that much serious about doing those long exposure things, then you can get yourself a basic Alt-Azimuth mount. It also comes cheaper in compared to EQ mount, let me tell you that. you can easily afford an alt-azimuth mount, and mostly if you buy a telescope, you might get, there are maximum chances that you might get the alt-azimuth mount only. So if you're not serious about making long exposure photography and you're just okay with some random observation of having a look into the surface of moon, or maybe some solar observation, or some bright planet like Jupiter, Saturn, rings of Saturn is also visible. So if you want to do those things, then alt-azimuth is good for you. I'm repeating again, if you add go to both the systems, then still the EQ is the one that wins, because of the sidereal tracking is perfect in EQ, but there is not at all sidereal tracking perfection in alt-azimuth. So that is the downside of it. If you add in alt-azimuth, if you add the sidereal movement by rotating the axis, or you can say the tube of the telescope, then it might work, but again it adds one more axis and it becomes a little bit more complicated. So that's a totally different topic. If you want a dedicated video on that, then also comment, I will make a video on that as well. So I think until here I have made a very clear explanation which one you should go for. So if you have any doubt, then you are free to ask me in the comment section. I hope you have liked this video until here. So see you in another video. Thank you.